I wanted to do a video of the Overclocked TI-59. I put in a 600 kilohertz ceramic resonator. That's all it can take. Well, it might be able to go a little more, but this is pretty close to its limit. I did try an 800 and it didn't work. That was too much for it. So the 600, which means that it's got a clock of 300 when it's in operation. So that's quite a bit more than its original 230 absolute maximum specification. Anyway, it's quite obvious. I've had to speed up the card reader, not so much for the reading, but for the writing, because it writes so much faster. You have to move the card through it quicker in order to be able to have it be most optimum. What's nice is it also reads quicker too. So anyway, so what I'm going to do is I'm going to load in the standard diagnostic. And then we're going to run the diagnostic, which is here. And you'll be able to see this is much quicker than the normal diagnostic. You run that on your 59, that will take longer. So this would be about 30% faster than normal. Now, the clock also feeds the printer. So that means that the printer has been clocked faster, 30% faster. And that was a bit of a worry, but so what I'm going to do is I'm going to go ahead and I'm just going to list the program for the diagnostic. And you'll be able to see that the printer does great, but it's moving. Let me reset it to the beginning of that again. So the digits are clear, every dot is clear, everything seems fine. It's just really moving. So, but the good news is that the overclocking didn't overtax the printer. So that's good. I think, interestingly, there might be a little tiny bit more space between the lines. I'm not sure. But everything's sped up, so, you know, all the various timings, so it really ought to be the same, just faster. And it's still being clear, so so that seems to be all right. So what I'm going to do is I'm going to clear the program, and I'm going to put in the more difficult memory test out of the service manual. So what this is going to do is this is a real test. This will actually read and write every memory location as fast as it can, and just, I mean, if there's going to be a problem, it's going to show up here. So this takes a little bit to run, but this is also a really good timing for, you know, how long it takes. It'll also, any kind of errors that it finds, it'll print out on the printer. So let's go ahead and give that a whirl. I'll let it go through once, just to show that there's no errors. But then, you know, I'm going to let this thing run for days like this, just, you know, testing itself, see how hot it gets, that kind of stuff. The other mods that I did, make the little computing digit, you can't really tell in the video, but it's a lot crisper when it flickers now, which is kind of nice, kind of cool. And this 59 is strictly for testing. I'm using one that's, you know, not the best of conditions in every respect, but it's a unit that, you know, if it explodes, I won't be unhappy. So once I'm sure that all the mods are good, then I'll go ahead and commit a good calculator to all the mods. I've got some pictures of the other mods. I've put some other caps in, done some other work on it, replaced the card reader IC, the 324 with the 324A, a new one, and also replaced all 4 caps for the tape reader, which makes it just read and write really well. And a bunch of other little mods for performance from the power supply. It's much quieter, much more stable unit. I'm using I don't have it right here, but I'm using 6 volt DC power This produces a voltage on the battery that's about 5 volts per cell, which is what you really want in order to be able to charge up the nickel metal hydride battery packs. So, but it will also run on a 6 volt, 1 amp supply, DC supply, without a battery perfectly. So I highly recommend that. That way you don't have to, you can just put a blank back on it and then just run it strictly from the power and only use a battery when you need to. Because leaving a battery in it's just really bad for the battery, and the corrosion eventually gets on the calculator and you're in trouble. So anyway, so yes, this does take a little while to run. Well, I guess we did already get one pass. That's what it prints when it's finished with one pass. We'll wait for another one. Oh, there we go. Yeah. So there you go. So it's made its pass, and all is well. So it looks as though it's clocking it at the 300 kilohertz clock, which is a 600 kilohertz resonator. So all looks well. I'm going to test it real heavy duty for days. I'm going to run this same program in a loop. Well, I've got a program that's also got the diagnostics on it, and it checks itself and just runs in a continuous loop as hard as it possibly can, doing everything it possibly can. So I'm going to do that shortly. Like I said, the main thing that I found was that I had to speed up the card speed in order to make it happy. But the cards are still totally readable on other machines, and you can read other cards just fine too. So it doesn't affect interoperability with standard units. So that's all good. Anyway, there we go.